This is Outbreak News This Week, brought to you by the Global Dispatch Incorporated. Outbreak News This Week is your source for all the news about worms and germs. And now, your host, microbiologist and editor of OutbreakNewsToday.com. Here's Robert Harriman.
Well, good day, Tampa Bay, and welcome to Outbreak News This Week. And happy Lab Week. Yep, today marks the beginning of Lab Week 2019, this annual celebration of medical laboratory professionals who play such a critical role in healthcare and diagnosis of patients. Well, for like the third year in a row, I'll be talking to Dr. Rodney Rohde from Texas State University, and we always go over a lot of information about the profession and where it's going and what you need to do. So check that out. Well, Dr. Rodney Rohde, how are you doing today, my friend?
I'm doing great. How are you today, Robert?
Excellent. Well, another year, another lab week, and which is always a great time to tell the world about the medical laboratory profession, something you once described as the hidden profession that saves lives. But before we get into discussing the profession and all the great aspects and the prospects of it, can you introduce yourself to the audience? Who is Dr. Rodney Rohde, and discuss your travels in the laboratory field?
Sure. Thanks, Robert. It's always a pleasure to be on your show. So my travels are kind of interesting, I think. I started in my career in public health and actually worked in the world of public health and infectious diseases for about a decade at the Department of Health in Austin, Texas, and also served as a visiting scientist at the CDC for a couple of summers, and really ran around Texas and other parts of the country kind of looking for rabies and hantavirus and other types of agents like that. Really loved that career. But in 2002, I had an opportunity to transition to academia, and I returned to my alma mater, which is Texas State University. And I've kind of worked my way up the academic ladder, if you will, from assistant professor all the way to full professor. And I became chair of the clinical laboratory science program in 2013. I also serve as the Associate Dean of Research in the College of Health Professions. So I like to tell most people that I have kind of a hybrid background. In one side of my career, I've been a public health microbiologist and infectious disease expert. And now I'm currently a chair and kind of research person within the academic setting. And also, as you know, producing future laboratory professionals.
Right. Important stuff. So that leads right into my first question. Dr. Rohde, what exactly is a medical laboratory professional?
Sure. So laboratory professionals, specifically medical laboratory professionals, really fill a role of providing the primary diagnostic data with respect to any types of patient results in laboratory medicine. So we're often in the hospitals. That's probably 80 to 90% of where my graduates and I have worked. And then the other 10 or 15% of our graduates will work in public health or reference labs and other areas. But really, we provide the laboratory medical data for physicians and others in healthcare to make the determination of your health and really your healthcare plan.
So what are the different paths that someone could take in becoming a medical laboratorian?
There's actually quite a few ways to get there. The most direct route is to either become a medical laboratory technologist, an MLT, or a medical laboratory scientist, which is a 4-year degree. So the first one is an associate's degree, kind of on the front end of the career. The second one is the primary 4-year degree person that also fills a need. And then, as you know, we'll talk about perhaps later, we've extended that into the graduate level. But that's the most primary way, is to attend an accredited program in an academic setting, go through that program, and then when you're done with that program, to sit for a bench level national certification and or license to practice.
So can you talk a little bit about the curriculum that someone would encounter if they went into this profession?
Absolutely. I often tell those in the general public, what's really interesting about our major is that our students really have to major. It's like majoring in 4 areas. They typically are going to take curriculum in clinical microbiology, clinical chemistry, clinical hematology, and something called immunohematology, which most people know as blood banking. So it's really 4 significant and rigorous areas across all spectrums of clinical laboratory medicine that they have to be competent in. And on top of that, they also have to understand the regulatory issues that surround the medical lab. They also learn quality control and assurances and a variety of management and clinical research skills. Quite a rigorous program.
Yeah, and unlike a biology or chemistry degree, there is a clinical rotation that goes along with this also.
Absolutely. So typically in most programs that comes a little later. For us, for instance, they do about a year and a half of kind of your typical didactic lecture and laboratory coursework. And they also are preparing for clinicals. One of the last courses they take prior to a clinical rotation is a bridge course that starts preparing them for competencies. But in the last 6 months, you're correct, our students go out into a number of different hospital affiliates that we have around Central Texas, for instance, and they do full-blown rotations, clinical rotations in each area of the lab. So a microchemistry, hematology, and a blood banking. And then they also have what's called as a general rotation, which is kind of a floater between all those areas, as well as kind of unique, enriched skill sets.
So if there's a prospective student that wants to get into this field, is there any specific accreditation of the program that they should be looking for? What's important?
Absolutely. So if you're a student looking to get into the medical laboratory academic setting, you would definitely want to make sure that program is NACLS accredited. NACLS is our primary external accrediting body. They basically ensure that our standards are upheld within the academic setting so that when you graduate, employers know that you have reached these certain bench level competencies and that you can perform those at a satisfactory rate.
Now, someone come out of high school or someone in high school, how should they prep themselves if they're looking at medical laboratory technology, for example, as a profession?
Yeah, the best advice I can give students that are in the high school age is to look at those core courses that we just kind of mentioned, if they are available. So upper level and kind of honors mathematics or those types of courses that are going to challenge them. Anything that kind of gets into the medical side of biology and or chemistry. Again, in high school, this may not be the perfect course, but anything that's going to at least touch those areas is going to be very helpful. And then, of course, the coursework that's more advanced around those areas, anatomy, physiology, things that might help you understand systems of the body or other types of things that align with medicine. And then I would also tell students that are looking at our program that if they can kind of challenge themselves with casework or investigative work, or where they're doing more writing intensive types of coursework, their presentation skills, all of those will really transition well into our type of major.
Yeah. And you've already touched on that there's an associate degree level, a bachelor degree level, but there's also graduate levels all the way up to the doctoral level now. Can you go ahead and talk about the master's and doctoral level degrees available?
Sure. So it's really interesting. For quite a while now, there have been master's level programs at the clinical lab science level. Sometimes those are in specific areas like management or maybe a specific discipline like blood banking and so forth. More recently, literally in the last couple of years, there have been some programs that have come out with a doctoral degree called the Doctorate in Clinical Laboratory Science. So these are typically referred to as the DCLS. And there are 3 primary programs in the country right now. One is at Rutgers University up in New Jersey. One is at UTMB Galveston, which is in Galveston, Texas, in my home state. And then there's another one with the Kansas Medical Center. And so those 3 programs now are in full swing. We've had our first graduate. Dr. Brandy Gonzalez is actually out practicing now, and others are in the pipeline and being produced as we speak. It's really an exciting degree that it's going to allow professionals to kind of bridge the gap between laboratory medicine, kind of at the bench level, and what's kind of missing from the physician side, either in their expectation of what that laboratory test means, as well as sometimes actually just knowing which tests to order. As you know, Robert, there is a vast array of panels of tests you can order and different interpretations of those tests.
Yeah, and just to the audience, I've talked to Dr. Rohde about medical laboratory profession several times on the various platforms, and there is actually a podcast out there concerning just this doctoral level degree, and I will link to that on the show notes for this show. Another important aspect of being a medical laboratory professional is professional certification, and depending on the state, in the state of Florida, you require a license. Dr. Rohde, can you explain what all this means to the viewer?
Sure, I can try. It can be a little confusing, of course, but like any kind of healthcare field, and in other fields, I mean, there are kind of these licenses or certifications, if you will, which are a credential that you sit for. So in our field, we have something called the MLS certification. It's given through the Board of Certification by ASCP. That's the primary certifying agency. There are some others out there like AMT, but these are tests that after you graduate from an accredited program, you are allowed to sit for. So you can sit for the MLT at the associate's level. You can sit for the MLS, which is my 4-year plan. And then there are specialist categories. For instance, I'm a specialist in microbiology and virology that I set for later. So all of those are actual theory-based tests that you sit down and take after your program director approves you. And once you pass that test, then you are able to place those letters behind your name, much like any other professional, like a nurse or a physician or so forth. In hospitals, in many states now actually require those for you to work. In some states, we have licensure, which actually accepts the ASCP credential as the license. There's just some extra paperwork, usually in a small fee. There's a couple of 3 states that it's a little more complicated. They have a little more involvement around the types of coursework that are required, as well as the number of clinical hours. And this is not a huge deal, but it's just something you have to be aware of if you're going to practice, for instance, in California, New York, and even Florida might have some unique kinds of preferences around there. But the good thing about this, of course, is that when you have that credential, it shows the world that you have that competency and knowledge base to practice in a hospital laboratory and really kind of keep that kind of quality there for all of healthcare.
Do you see state licensure in the medical laboratory profession to become all 50 states at some point, the way nursing is?
You know, I think if you would talk to, certainly I think it's an important thing that I hope happens in my life. If you talk to my colleagues, many of them would agree with that we're not sure why it's not a licensed type of issue around the country. As you might know, in Texas, I've been president. I'm actually past president of TACLES, which is our state organization that aligns with our national organization. And we definitely are in support of licensure in all states. It's a complicated topic. I've actually written some articles about this that kind of clarify all the nuances of it. But we do support that stance, and it's really going to come down to right now, it's almost a state-by-state issue because we don't really have a national level for a licensure for our profession. They typically grow out of the state-to-state kind of form. I think at last count, there's about 13 states, 12 or 13 states that require licensure. And so we're hoping to build on that as we move forward.
Okay, so the individual, they get their education, they get their certification and license, and now they're ready to work. Dr. Rohde, what kinds of duties might one expect in what kind of environments?
Sure. So again, as I mentioned earlier, the primary role of our graduates is to work in a hospital or medical laboratory. And usually we actually encourage our graduates to become generalists. And so as soon as they graduate, all of their knowledge is very fresh. And so we actually encourage them to work as a generalist. It's also the most sought after position. So that means the person can work in all areas: micro, clinical chemistry, blood bank, and hematology, as well as kind of oversee the different things that they might do in a typical area by bouncing around the different areas. That's a kind of a typical starting point. However, there are ways to perhaps work only in blood bank or only in microbiology. If you're out there looking for those types of positions, they are available. And so that's a route as well. Sometimes our students will work in a variety of other areas. If we start talking about outside of the actual hospital medical lab, I don't know if that is something you would like to discuss, but there are those types of positions in public health, for instance, and industry and so forth.
Yeah, we'll jump on that in a couple minutes.
Sure.
All right. So, Dr. Rohde, what are the job prospects for a fresh graduate today?
You know, if you're looking in my experience, there are plenty of job prospects. We often tell our students and their parents, for that matter, or their loved ones, that our graduates have 100% employment within weeks, if not maybe a month of graduation. So remember, our graduates have done clinical rotations in a variety of hospital affiliates. And so many of those affiliates, and this is true of all the programs around the country, they're literally trying out, our students as they're training. So they're often going after them and encouraging them to apply for positions. As you know, Robert, this is a major shortage in healthcare for our profession, much like nursing. We have huge shortages across the country, really in all markets. So it's really not an issue of finding work in a variety of hospital settings and elsewhere, for that matter.
Yeah. And a question I'm sure a lot of people would be interested in is, how is the salary for a job like this?
So it depends, as you know, it kind of depends on the geography and where you're starting. But I'll just give you kind of the median type of starting point. If you're looking at the hourly rate, typically it's anywhere from $18 up to $25, $26 an hour in Texas specifically. That probably equates pretty equally across the country. That typically works out to 50 to 60K, maybe a median somewhere kind of in that range. Again, depending on where you live, it can be higher in the Northeast, for instance. If you're talking about Texas, you're probably going to earn more money in the Dallas-Fort Worth area or Houston, the kind of heavy, big, large populations. And then again, remember in our field, if a graduate is working in those areas and they're willing to work the night shift, or if they're willing to work weekends or holidays and things like that, they get a shift differential. So what that means is all of a sudden, instead of $25 an hour, you might be making $29 or $30 an hour, and that really can help your salary.
Yeah.
And then with time and experience, it also increases with management and things like that.
Sure. Now, many medical laboratory scientists actually spread their wings and take their skills into other types of work, in which you were talking about moments ago. Pretty marketable. What else do medical laboratory scientists do along their career sometimes?
Sure, there are just so many. Really,
you're one example.
I am one example. Education. Let's start there. We have a major issue coming up with all of the retirements of the boomers. So there are so many faculty positions in clinical lab and medical lab science programs that it's scary. I get dozens of openings across the country just in education alone. So those typically require a master's degree, but certainly we are looking for faculty. So that's something that people that love training or educating students sometimes find themselves looking at. There are positions in our state meeting last week. We had a young lady that was one of our 2010 graduates, and after about 5 or 6 years on the bench, she started connecting with an industry partner and started doing troubleshooting and installation of these types of equipments across the country. She loved that so much and found she could do a good job at it that she got into sales, and so now she's selling major laboratory equipment all across Texas and parts of the state. Again, those are kind of unique, interesting things. We have students that move into the regulatory area, so those people that inspect labs and do different types of laboratory regulation inspections. We have people that sometimes go into veterinary medical diagnostics. That's kind of where I came. My background was, in rabies and things like that. So there's this whole area of the veterinary health area that people can work in. And just it goes on and on and on, even secondary education. So sometimes people want to get back into the K through 12 education and teach, which is really helpful because they can really turn students onto our field early on. So just a number of things. And then we don't want all of our students to leave the medical lab, Robert, but I mean, certainly we have shortages, right? But some of our students, I'd say 1 or 2 out of every cohort of 20 or so, will go ahead and go into, say, physician's assistants program or even med school. Our curriculum and coursework is very useful in preparing you for medical school and pathologist assistant programs and things like that, or even PhDs and graduate work in kind of the clinical research world. So some of ours do go that route.
Now, as I mentioned at the beginning of the show, you once described this profession as the hidden profession. Not a good thing, but is it improving? Is this still true?
I think that moniker is actually starting to kind of fade, and I hope it's because of myself and other people out there hammering on the pavement and on your show and other shows, and that's why I always appreciate you allowing me to kind of have this platform to discuss the medical lab. But yeah, that article that went viral back in 2014 or 15 is something now that I often like to talk about is fading. I really think we are making an impression at the national level about how critical our profession is. And that DCLS and those diagnostic kind of management teams that my colleague, Dr. Michael Laposada, talks about often at Galveston is really going to put us in front of patients. It's going to put us in front of nursing and physicians and PharmDs and others that are in the trenches of the visible healthcare professional. And I just see it improving as we go along. It is still incumbent upon our professionals, current, the older kind of techs that have been around for a long time, as well as the ones coming out, to stay in that kind of mindset that we have to get out of that lab and be more of a visible presence in our communities and describing what our jobs are, visiting high schools, visiting junior high schools, and discussing our career path and how exciting it can be.
All right. Well, that really brings me to what we're here for in the first place is Lab Week 2019. It's from April 21st to April 27. Pretty important week for the profession, right?
Absolutely. It's a great time to share the very thing we were just talking about, not only to celebrate our profession and how many wonderful pioneers have come prior to me and others and where we're headed with new pioneers, but certainly it's an opportunity within healthcare and elsewhere to kind of shine a light on our profession and, do some of that mingling with other healthcare professions, get out there in the public eye and talk about this profession. And of course, the social media aspect's really important, to share that across the spectrum with kind of the new generation of professional. And that's what I'm planning on doing. So not only with your podcast, but Dr. Laposado and Dr. Gonzalez, the first DCLS, we're putting together an article specifically discussing the DMTs and the DCLS. And so keep an eye out for that. That'll be out during that week, if not a day or two before, and hoping to kind of push that and other things surrounding that particular week.
Okay, so just as a reminder, Lab Week 2019 starts on April 21st. I believe that's a Sunday. And any final thoughts on the clinical laboratory profession, Lab Week, or anything else, Dr. Rohde?
One quick thing that I would like to add, and I've been discussing this a lot with my colleagues and kind of reflecting on it over the past few years, and especially last week because I just got back from my state conference, is one of the areas that we really want to share with our audiences is the new professionals and how excited we are about kind of the 22-year-old to 30-year-old kind of recent grads that are really starting their careers and venturing out, is how critically important it is for them to stay connected to the professional through their state, local, and national organizations to become kind of promoters of the profession and to help us share that awareness. So I thank you so much for giving me this opportunity, as always, to share this importance.
Well, Thanks again, Dr. Rodney Rohde, for joining me for another Lab Week. I really appreciate it, sir.
Thanks, Robert.
Okay. And after the break, we'll go ahead and talk to Dr. Vincent Racaniello, virologist extraordinaire.
Welcome back to Outbreak News This Week, your source for all the news about worms and germs. Here's your host, microbiologist and editor of OutbreakNewsToday.com, Robert Harriman.
Well, welcome back to the show. Now, Virology Blog was the first science website I ever followed. It's been quite a few years now, and it was really an inspiration to me in using the internet to disseminate information on infectious diseases and up-to-date outbreak news. And because of my guest today, I saw a real value in this type of reporting. In addition, my guest today is a renowned virologist, particularly in the research of poliovirus. So please welcome to the show, Professor of Microbiology and Immunology at Columbia University, Vincent Racaniello, PhD. Dr. Racaniello, thanks for spending this time with me today, sir.
My pleasure as always, Robert.
Now, you were the keynote speaker at last year's American Society for Virology meeting, and your speech was entitled An Inordinate Fondness for Viruses. And I clearly had a chuckle when I saw that, which I believe sums up at least your professional life. Can you expound upon this inordinate fondness?
Sure. It's a little take. First, of course, it means that I have an inordinate fondness for viruses. I have developed an incredible love for them over my career. You said it's my professional life, but I think about them all the time. They are just amazing to me. So I thought that would be a cool title. It's really based on a book and a statement made by the evolutionary biologist J.B.S. Haldane, who said a long time ago, someone asked him, what does the fact that there are so many beetles on Earth mean about the creator? And Haldane said, well, if there were a creator, then that would mean that the creator has an inordinate fondness for beetles because there's so many of them. And so not only do I have an inordinate fondness for viruses, but there's a ton of them out there. There are way more viruses than beetles. So I thought it was about time to update that little statement from inordinate fondness for beetles to an inordinate fondness for viruses. So that's where that comes from.
Very clever and very appropriate. And what I like to do on the show is I like to introduce the audience to some of the great minds in science and medicine. And I want to start with... That
means I have to leave now.
Okay. Turn the page. So let's start with some background. You got your doctorate in the laboratory of Dr. Peter Palese. Hope I said that right.
Palese.
Back in the 1970s. What type of research did you do for your dissertation?
Well, Peter Palese was and still is a great influenza virus virologist. And when I got to his lab, which was 1975, 76, he had been working on influenza viruses for a couple of years. This was at Mount Sinai in New York City. And he had developed, this is again now pre-recombinant DNA, pre-sequencing of genomes. He developed a way to map the 8 RNA segments of influenza viruses and figure out what protein was coded by each one. The viruses, as you know, have 8 segments of RNA. And we didn't know what each one did. So he had figured out a nice technique to do that. And when I came to the lab, I was really fascinated by viruses already at that time. He actually said to me, what do you want to work on? So I said, well, I'd like to take that mapping technique and use it for the influenza B viruses. And this was a group of influenza viruses which didn't get as much respect back then as the influenza A viruses, but now, of course, we include them in the vaccines against influenza. So I said I wanted to map the genome of these viruses, and he let me do it. And I figured out how to separate the RNAs and figure out what proteins went with each one. And then towards the end, I said I want to do the same thing for influenza C viruses. And so I did that as well. And the big surprise there was that they were missing segment. There are only 7 in the influenza C viruses. So I got a great training in basic virology, and he was just a fabulous mentor.
Good stuff. Good stuff. After that, you joined the lab of David Baltimore at MIT. Who is David Baltimore? That name does sound familiar to many.
David Baltimore is a really well-known American virologist and scientist. He won a Nobel Prize in the 70s for co-discovering with Howard Temin reverse transcriptase in retroviruses. And when I got to his lab, it had just been a few years since he'd won that Nobel Prize. His lab was hopping, and it was just a wonderful place to be. He's a brilliant man.
Is he still alive also?
He is. He just turned 80 last year. I went to his birthday party, and he's now at Caltech.
Okay, good. Now, at this lab, you started making some serious advances on poliovirus.
Yeah, when I went there, the moratorium, first of all, in the 70s, recombinant DNA technology had just been developed. The ability to take an RNA and clone it as a DNA copy in a bacterial plasmid and change it and sequence it. And so he said, I want you to clone the genome of poliovirus. And I did that. And it was fitting that I'm in the lab of the fellow who discovered reverse transcriptase. And of course, I'm using that enzyme to make a DNA copy of poliovirus. I cloned it in a plasmid. I determined the entire sequence of the viral RNA, 7,442 bases. Wow. And that was among the first animal virus genomes that had been sequenced. And of course, that told us how the genome was coding for proteins and so forth. That was laid out. And then I took that plasmid that I had made of the whole genome, and David said, why don't you throw it into cells in culture and see what happens? And I said, well, nothing's going to happen. It needs a promoter. He said, no, Vinny, just do the simple experiment. So I took this plasmid, I put it in cells, and out came polioviruses. It was the first demonstration for an animal virus that you could get virus back from a cloned DNA copy of the genome. So that was a really big finding. And I took that with me, of course, to my job. So I was really lucky as a postdoc. It was less than 4 years. I made 2 pretty important findings. And I think that being in a lab like David's, where there were lots of smart people around, lots of resources, really helped me do that.
Yeah, that's amazing. And the work with the polio eventually became your life's work, for a better, lack of a better term.
Absolutely. I took poliovirus with me. Now, you have to understand, when I left Peter Palaisi's lab, I had all intentions of going back to influenza virus because that was a really interesting virus as well. But after having made these discoveries with polio, I said, no, I'm going to work on polio. I took it with me to establish my lab here at Columbia University, and I've worked on it pretty much ever since, 1982 I came here.
A lot of decades there, right?
So what is that? It's almost it's 38 years, right?
Yeah, that's a long time. But poliovirus is kind of being taken care of, for lack of a better term. So you've been working on enterovirus now.
Yeah. So as you know, in the '88, the WHO said we're going to eradicate polio, and so I'd only been here 6 years. And but we kept working on the virus. But in the meantime, they made pretty good progress. So last year, there were less than 200 cases of polio globally. So we've always looked at other viruses to work on, although to this day, we still have a polio project, which is really interesting. But over the years, we've worked on rhinoviruses and other enteroviruses. We've turned to enterovirus 68, which recently has been causing childhood paralysis. We've even worked on Zika virus. There's certainly no shortage of RNA viruses out there to work on now.
That is a fact. So you've been at Columbia since '82. Can you talk about some of your experiences there? I mean, you must have many.
I do have a lot of experiences. Someday I'm going to write a book. And, when you write, you sit down, it makes you think back and remember things. Because right now, I think everything in the past is kind of fuzzy. But some of the experiences, I came here, and my chairman said, "Here's your lab," and he left, and it was up to me to get the lab started. It's an empty room, so I had to figure out how to do things. You learn how to go to your colleagues and ask for help, and then I got my first people had no shortage of projects, but I had to get people to work on them. I got the first people in my lab. I was lucky for many, many years to have wonderful graduate students and a couple of postdocs to do the work, and no shortage of problems to work on. So I always found challenging how to train people and get them to be good scientists, to motivate them to be respectful of others, and that's a challenge. And so I think most of the time it worked, but not always. And I've found that over the years, getting financial support for your work is not easy. So it's important to push your work forward, to talk about it, and to write about it. And so those are the challenges, I think, in being an independent investigator. And I think it's harder now because money is tighter, jobs are tighter, and people coming in the fields now are going to have different challenges.
Well, not only are you a researcher, but you're also a teacher, and I'm sure you enjoy that aspect also.
I love teaching. I didn't realize when I started that I would love teaching so much, but when I did, even as a graduate student, I remember when I gave talks, I really enjoyed talking. I really enjoyed being clear in my talks. People always said I gave good talks. And so over the years, I always accepted invitations to teach or to talk. And then at some point in the 90s, I was asked to join a team that was writing a virology textbook, and that became Principles of Virology. And it's now, we're working on the 5th edition, so it's done very well. And I've used that to create a virology course here at Columbia University. And I'm teaching it right now. I teach in the spring semester. I absolutely love teaching virology. I'm passionate about viruses. Of course, I'm crazy about them, but I can convey that to the students. And here they can have someone who has spent his life doing research on viruses teach them about it. And they really enjoy that. And it's a very popular course. So, I am at a medical school, which is basically like a research institute. You really should do research and raise money to do that. And teaching is not a primary focus, but I just love teaching. And if I were to do my career again, I probably would go to an undergraduate institution where I could teach more. Yeah.
I've heard other people say that also. Another of your passions, and really how I discovered you many years ago now, was virology and microbiology media, thanks to the internet. In fact, I was following Virology blog. That was the first website that I followed as far as a science website.
Neat.
And I'm not sure if you know this, but the July 4th weekend of 2013, you were my first radio guest, and we talked about MERS about 1 year into it. Yeah, you were the first one because of Virology blog. I said,
"Oh, cool."
Well, I want to talk about MERS, but there's this guy that runs this blog. Let me contact him. And that's really how. So it's amazing what these things can really do, right?
Yeah, that's a great story. And I've talked to you many times over the years for your radio program, right?
Yeah. And so you started the Virology blog in the mid 2000s sometime.
Is that 2000 and 2006, I think. Something like that.
Yeah, so it's been a long time. You were one of the first, as far as I can tell. What was your goal at the time, and how surprised are you that it did so well and then led to all these other opportunities that you're involved in now?
Well, the reason I started it was we had just finished writing the first edition of this virology textbook. And the way the book is written, I had to write about a lot of viruses that I wasn't necessarily working on, and learned about them. I had all this knowledge. I said, I want to share this. And our publishing contract allows us to put material from the book online. And at that point, blogging had become easy. WordPress was around. It was easy to get a hosting provider. And so I thought, why don't I start writing a blog and just take parts of my book and publish that? So I started doing that, and the first post was something like, are viruses alive, or something like that. And I had no idea where it would go, but amazingly, people started reading it and leaving comments. I was just, 10, 20 comments per article. So I started, at first it was rather infrequent, but then I started writing more and more. And of course, the more you write, the more people read. And now I'm still doing it. I do it once a week. I write something. I still have a really big audience reading that. And I've been able to get two other people to write on the site as well, to do their own thing. And I'm amazed always at how many people actually read it. So my original goal was simply to teach people about viruses. I wanted to write because I do like writing very much. But it introduced me to this whole world of social media. And of course, that led to doing podcasts and video, Twitter, YouTube, and Facebook, and all of that. And I found that was a great outlet for teaching science to people.
Yeah, and I could speak for myself. You were really an inspiration for me to get involved in the different types of medium also. Can you talk about the importance of this medium, the internet and the social media, and including the podcasting and the various videos and stuff that you do?
Well, first of all, it's important to realize that science is really important for everybody's lives. The way we live today, the longevity, our health, all the gadgets that we have, all of that is because of science. But I think few people understand that and appreciate it. So it's really important for scientists to talk about what they do so people learn it. Pre-internet, you couldn't do very much in terms of communicating science. Right. You could write books, you could give talks, you could go to schools, for example, but you never reached that many people, and it was typically local. But the internet changed all that, because now you have not only websites, which are great, and you can reach a lot of people, and now the cool thing about websites is that everybody looks at them on their mobile devices, right? It used to be you were chained to a desktop. Now 80% of web traffic is mobile. People read you read your blog while they're waiting in line. That's great. And then, of course, the internet enables social media, Twitter and Facebook and Instagram, people sharing things quite readily, and podcasts. And all of this stuff democratizes knowledge. And what that means is anybody that wants to publish something can do it. So in my book, scientists have this great audience out there. They can teach the world, basically. You pick your medium. You can write, you can do podcasts, you can do videos, you can go on social media and talk to people. You just pick your medium, and it's easy to do. It's inexpensive. For podcasts, you don't need a radio station. You don't have to have a transmitter. You can just do it in your office and put it out there, and people can listen to it and consume it. So for science communication, it's perfect, and it's also bad because you have a lot of people out there who don't know anything and who are expressing their opinions, and they are apparently on an equal footing as the experts, and that's the problem, both the blessing and the curse of the internet.
Yeah, that's really how it works too. Boy, I got a lot of I have a Facebook page that has nearly 70,000 people on it, and the anti-vaccine crowd comes out in force, and
yeah,
it's
absolutely.
But I don't block anybody unless they get dirty and nasty. So I just let them do their thing. There's people on there that are pro-vaccine that counter them, and they just watch them go to battle, and it's fun. It's fun to watch, I think. Let's go ahead and switch gears to virology, your topic. Many changes in the field, and very rapidly. What was the most significant advance that you've seen in your career?
That's a tough question, Robert, because since I've been around a bit, a lot of things have happened that have been really, really important.
Well, it could be more than one, Dr. Racaniello.
The first one that really affected me was, of course, recombinant DNA technology, the ability to make DNA copies of any RNA or DNA and amplify them and modify them. And we use that to this day, of course. It's revolutionized research. It's revolutionized the pharma industry. You can make therapeutic products that way and so forth. So that is the one I've known the longest. It enabled me to make a DNA copy of poliovirus and determine its sequence and make it infectious and all that. So that would have to be at the top of the list. But, I've also seen polymerase chain reaction developed in my career, and that's been huge, of course, as well in research and diagnostics. But I think that I would make number two probably genome sequencing, because when I was in the Baltimore lab, it was in its infancy, and I used it in a very crude form. I have to tell you, I sequenced the genome of poliovirus, 7,442 nucleotides. It took me a year to do that because I did it by myself by hand, and that's how you did it back then.
Yeah.
Nowadays, of course, it could be done in half an hour. You would mail the DNA to a company, and they would give you the results the next day. And that has transformed the way we look at viruses, because when I started my lab, realistically, I could only work on one virus, poliovirus, because that's all you could sequence. It takes so long to do that. But now you can work on thousands of polioviruses. You could go around the world and collect isolates and sequence them all and compare them. And that's totally revolutionized virology. So I'd have to say sequencing would be a close number 2. You have to get DNA copies of genomes before you can sequence them. But sequencing has made huge contributions to understanding epidemiology, pathogenesis, evolution of viruses, stuff we never knew before.
So you're up at Columbia University. For people that don't know where that is, that's in New York City. So Dr. Racaniello, right in your backyard right now, you got a pretty large measles outbreak for the United States, for sure. What are your thoughts on what's going on with measles throughout the country?
This is a virus which shouldn't be around, because we've had a vaccine since the 60s. It's the same vaccine. It's a great vaccine. It works really well. It doesn't harm you in any way. And so all of these cases are inexcusable in my view. Should not be happening. They're totally vaccine preventable. And they're arising, of course, because in both cases, in Rockland County and in Brooklyn, we have religious groups whose leaders are suspicious of the vaccine. And of course, the members of the religious groups listen to their leaders, and so they don't vaccinate their children. But there is no reason not to use measles vaccine. It had some very bad press in the 90s because of Andrew Wakefield's suggestion that it might be causing autism, but his studies have been thoroughly debunked. And many, many studies have been done since then, which clearly show that the virus vaccine, the measles virus vaccine, is not in any way connected to autism. Yet this persists. People still think, and that's why they're suspicious of it. So I'm very sad when I see these kids getting measles, because it's totally preventable. The vaccine will not harm you in any way. It's easy to get, and it could kill you. Measles can cause encephalitis in 1 in 1,000 infected kids. So I think this is not ending yet. I think and I'm very happy to see New York City and Rockland County take measures to tell people that you have to be immunized. But I don't think it's going to be over anytime soon. I think it's going to get worse for a while, because there are just pockets of people throughout this country and throughout the world who simply are suspicious of the vaccine. And we have to get a message to them that it's okay. And, that's part of what I've been trying to do over the years with podcasting and so forth. But I need more than myself. I need other people to help in this. And I always tell people, go out and tell 10 people that it's okay to get this vaccine. It's really something that shouldn't be happening in 2019.
Wakefield planted that seed, and I think it's going to be really difficult to totally turn this around. I mean, people.
It's remarkable. It's remarkable, really.
Unbelievable. Yeah. I'm not sure if you can answer this, but let me throw it out there anyway. There's some controversy concerning some of the news media talking about immigrants from Central America bringing enterovirus D68 into this country and causing the 2014 AFM outbreak and subsequent years. Do you have any thoughts on that?
I think that's a crazy idea, because, entero D68 was first isolated in California in 1962.
Yeah.
And so it's always been around. In fact, I'm sure it was around before that. We just didn't notice it. Why we had an outbreak in 2014 is a really good question. It certainly wasn't brought over any border, because we've had it here, and it's present in many other countries throughout the globe. But it's very curious. We had an outbreak then. We had another one in 2016 and another one in 2018. I don't really understand why we're having outbreaks now and why we didn't have before it. Maybe we never detected it. But the idea that it came over the border, I think it's crazy.
All right, I hope you enjoyed today's interviews, and I will see you next week at Outbreak News This Week. Good day, and God bless.
Thank you for listening to Outbreak News This Week with Robert Harriman. If you missed any part of today's program, you can listen to the podcast anytime on our website, outbreaknewstoday.com. Make sure to join us here next week for Outbreak News This Week with Robert Harriman.